Hello dear friends, and welcome back to our channel. So friends, in today's channel we shall be looking at the integral of the square root of x times the square root of x then the square root of x. It keeps on going forever, guys. We have these three dots, which means it keeps on going forever. So friends, I got this question from the 2020 integration B qualified exam. So friends, it is a test for the people who want to participate in the 2020 MIT B qualified exam. So guys, they gave 20 questions and you have to answer for 20 minutes. So friends, we shall be looking at this question today because I was going through the questions and this question interested me most. Okay, so I want us to look at it. So friends, if you're new to this channel, don't forget to hit the subscribe button because we shall be uploading so many interesting content here for you, and you can only have access to those contents fully, guys, once you've subscribed. So let's get started, friends. That's great. So we have the equation here on screen. So guys, let's start solving it. So friends, I'm going to be explaining all the steps. I'm going to be explaining so well qualitatively, so that you're going to understand so well, and if you meet a similar question like this, it shall not be an issue for you to handle. So friends, let's start by looking at, because truth be told, guys, the first time I saw this question, the first time I actually saw it, I felt I wasn't going to answer it because the question looks very crazy, right? Yeah, it looks very crazy. So I felt that I wasn't going to solve it, but when I took a closer look at the question, I saw that there was something very interesting about the question that we could actually see it clearly. So friends, let's look at the function part. Okay, let's just observe the behavior of just the function part, just the square root of all of this. Okay, now friends, as you can look at this function part now, if we decide to look at the individual portions that make up the function one after the other, guys, if we look at just the first x, we'll see that this x is enclosed inside of what, guys? Inside of one square root, right? Wait, so this x is enclosed inside of one square root, and the square root of anything is simply going to be that thing to the power what? 1/2. Great. So we can write this guy as what? S to the power 1/2 times the square root of everything here. Then now friends, if you look at the second square root that I have it here in red, you will see that it is this same x, right? And it is enclosed by how many square roots? By 2 square roots. We have the original square root, that is the biggest square root, and the one in which actually encloses the second x, right? And it is enclosed in what, guys? In 2 square roots. That's to tell you that it is enclosed within 2 square roots, and in such a case we are going to have this first square root, which is going to be 1/2, then the second square root, which is going to be 1/2. So 1/2 times 1/2 gives us what? 1/4, right? So we can write it, we can have this x to the power 1/2 here, then this other x now can come outside now as x to the power 1/4. So we are going to have s to the power 1/2 times x to the power 1/4. Great. Then now friends, if you look at this, the third x we have here, right, you see that it is enclosed in what, guys? Into what? It is enclosed in the first big square root, the second square root, and what? The third square root, right, which is enclosed between what? Between you have 3 square roots, right? So in other words, we have x to the power 1/2, 1/2 again, then we have 1/2. Altogether gives us what? 1/8. So we are simply going to have x to the power 1/2, x to the power 1/4, then we have x to the power 1/8, and so on and so forth, guys. So if we continue this same process, guys, we are simply going to have, if we continue the same process, guys, we'll see that this our function part is simply just going to translate into x to the power 1/2 plus x to the power 1/2 plus x to the power plus x to the power 1/4 plus x to the power 1/8 plus x to the power 1/16. That is because we have these x's multiplying themselves, right? And in such a case, now the indices comes in to tell us that each time the bases are the same, we simply add their exponents or their powers. So that's why we have it here, and it keeps on going forever, guys. That's why we have these 3 dots, so it keeps on going forever. So friends, we can observe the pattern and see that just the power, just 1/2 plus 1/4 plus 1/8 plus 1/16, guys, we can write this as a general form as what, guys? We can simply write it as a series as n goes from 1 to infinity of 1/2 that to the power n. Great. 1/2 to the power n. So guys, we can write everything like this because if n becomes 1, we simply have the first term. If n becomes 2, we have the second term, that is 1/2 order to the power 2. We are going to have 1/4. If n becomes 3, likewise we are going to have 1/8, and so on and so forth, guys. So we can write this guy as this. So now friends, if we decide to make some observations, we are also going to see that that the series as n goes from 1 to infinity of 1/2 order to the power n now is simply a geometric progression whose first term is a equal to 1/2 and whose common ratio r is equal to what? Still 1/2. Great. You can see it by simply taking the second term divided by the previous term. That is simply going to give you 1/2 as your common ratio. Then the first term, that is a is 1/2. So we can see this guy as so we can see that this is a geometric progression in which the first term is 1/2 and common ratio is 1/2. So if we see that this our series keeps on going forever, right? So there are infinitely many terms. We have infinite terms. So now if we want to get now the sum of all those terms, we are simply going to indirectly be looking for the sum to infinity, and it is simply given as a over 1 minus r. That is for a GP. For a geometric progression, guys, it's given as a over 1 minus r. That therefore means that if we substitute all our values, if we bring forth our values, we are going to have a is 1/2, we have 1/2, all over 1 minus r is still 1/2, so we have it like this. 1 minus 1/2, guys, simply gives us 1/2, so we have 1/2 and 1/2, that gives us 1. Great. So now the sum of all of what we have here, guys, is simply going to give us 1. That therefore means that the sum of 1/2 plus 1/4 plus 1/8 and so on and so forth, guys, that gives us 1 only. So we are indirectly going to integrate this our integral, our indefinite integral, guys. That's the original function. That's the original integral that we have to evaluate. We saw that the function part was equivalent to what, guys? X to the power the sum of all these terms, right? And we saw that the sum of all these terms simply converges to what? 1, right? Because this our GP is actually a convergent GP, since the common ratio is less than 1. Okay, it actually converges, so all the terms are going to die down to 1. That therefore means that this our integral now will just translate into x to the power everything, but everything here is simply 1, so it simply translates into the integral of just x to the power 1, which is just x. And guys, I'm sure everybody, even someone who just started studying calculus for the very first time, can evaluate this, right? Good. So we do the reverse power rule. This is just going to give us 1/2 x squared plus c. Great. So friends, this is the question that we have. This is the very crazy question that is actually cheap. Okay, so friends, just put in the comment section down below what you think about this question. However, guys, this is the solution to the question. Thank you very much for watching the video, guys, and don't forget to subscribe to the channel and like the video, because that does motivate me enough to keep producing more and more content. Like I said, guys, this question was from the 2020 MITB qualifier exam. Okay, I took it from there. Great.